What's the difference between Bayesian and frequentist statistics? Have you ever wondered how data scientists make sense of numbers and probabilities? Today, we will break down the differences between Bayesian and frequentist statistics, especially in the exciting world of FinTech innovations and algorithmic trading. First, let's look at the core ideas behind these two approaches. Frequentist statistics defines probability as the long-term frequency of an event happening over many trials. This means that probabilities are seen as fixed and objective. For example, if you were testing a new trading algorithm, a frequentist would focus on how often the observed performance would occur if the algorithm had no real effect. They relying on tools like p-values and confidence intervals to test their hypotheses. On the other hand, Bayesian statistics views probability differently. It treats probability as a measure of belief or certainty about an event or parameter. This belief can change as new data comes in. In this method, parameters are considered random variables with their own probability distributions. For instance, in algorithmic trading, a Bayesian might start with a prior belief about how effective a trading strategy is, and then adjust that belief as more trading data becomes available. Now, let's highlight some key differences between these two methods. First, the interpretation of probability varies. Frequentists see it as the frequency of outcomes over many trials, while Bayesians view it as a degree of belief that can evolve with new evidence. Next, consider how prior information is handled. Bayesian methods explicitly incorporate prior knowledge into their analysis, while frequentist methods do not use prior beliefs and focus solely on the data at hand. When it comes to parameters, frequentist statistics treat them as fixed but unknown values. In contrast, Bayesian statistics treat parameters as random variables with distributions. This leads to another difference. Bayesian statistics can update probabilities as new data arrives, making it adaptive. Frequentist methods do not update probabilities but relying on fixed procedures. In the context of FinTech and algorithmic trading, Bayesian statistics have become increasingly popular. They allow traders to incorporate prior knowledge about market conditions and adapt to new data in real time. This flexibility is especially useful when sample sizes are small or when expert knowledge is available. Frequentist methods, however, are still widely used for hypothesis testing and performance evaluation, particularly when large datasets are accessible. These methods provide a traditional framework that avoids subjective prior beliefs. Recent advancements in computing have made Bayesian methods more practical for complex financial models. This means traders can make more informed decisions under uncertainty. In summary, frequentist statistics relying on objective long-run frequencies and fixed parameters, while Bayesian statistics treat probability as a dynamic measure of belief that updates with new data. In the fast-paced world of algorithmic trading, Bayesian approaches offer flexibility and adaptability, while frequentist methods provide a solid, data-driven framework. The choice between them often depends on the context, data availability, and the value of incorporating prior knowledge.